Today I'll actually be talking to you about Android things and kind of just like how to actually get started today. If you have kind of like any questions kind of just about Button as a company, feel free to reach out to me kind of just after if you have any questions about that. So with a show of hands, how many people here is familiar with Android development? And how many people here are familiar with Android things? Okay, not as many hands, but it's cool. So to kind of go over kind of like our agenda for today, we're kind of just going to go over kind of like a quick overview, kind of like what Android things is and why should you actually use it, and also kind of just like the history of kind of just like how it actually came about. And of course, how it actually compares to regular Android development versus just working with the Android Things platform. And of course, the good stuff like what hardware you can actually use with it. And of course, how to actually get started today. And I'll definitely leave time at the end. So if you have any questions, feel free to ask them at the end. So kind of just what is Android Things? Android Things is the Internet of Things operating system, and it allows you to kind of like build connected devices. In general, reading this, you're probably just like, what are connected devices? Connected devices are kind of just like anything kind of from like your smart thermostat that kind of just like turns up the heat when you first get home, or kind of just like a smart fridge that basically tells you that your milk is about to expire. So Android Things essentially allows you to actually build these connected devices with kind of just like no prior knowledge of kind of just like embedded system design. So it's great for kind of like hobbyists like myself, or just like any company that's kind of trying to make a breakthrough into like the IoT space. If you just kind of just start out with a pretty simple application and from prototype to production, you can use Android Things. And kind of just why should you actually use it? Well, in general, it uses the same tools that you'll normally use when it comes to normal Android development. So like the same libraries, such as like Dagger. If you want to use Kotlin, you can use Kotlin. The code samples I'm actually going to show you later on in this presentation, they're all actually going to be in Kotlin. But you can still obviously use them with Java with no problem. But in general, it reduces the upfront cost, whether if it's just like time cost, because you don't actually have to learn really anything new in order to actually use Android Things. So it's just like a few different APIs that you kind of have to know about, which I'll actually get into detail with. But everything else will kind of be the same, like the way you get it to run. You still use Android Studio with no problem. Any tools that you've used in the past should still work with no problem. All right, so this might possibly look familiar to everyone, and if it is, this is actually the Android framework, starting with like the Linux kernel. Then you have the hardware abstraction layer. Then obviously the native C and C++ libraries. You have the Java API framework along with the Google services, and of course like the user kind of like facing apps that we all here build. So kind of how that relates to actual Android Things is actually extends the core kind of like framework of Android. It kind of adds this unique layer called the Thing Support Library, which is basically a library that allows you to kind of just like interact with these low-level peripherals, which I'll actually get into a little bit more later. But in general, system apps are actually not in Android. In Android Things, it's just not a thing in order to actually run on these low-power devices. Apps are automatically launched on startup. It's definitely different to kind of like how your mobile device currently works if you do have an Android phone. But this is like some key differences between Android and Android Things. And with Android Thing, it only exposes one app at a time, as opposed to like multiple apps at a time, like your phone or like tablet will actually do. So to kind of get into like the history of Android Things, about 3 years ago, it was announced at Google I/O in 2015, and it was under the name Project Brillo. Android Things was the name that came out kind of like a few months after, in December, when they actually released the actual first developer preview. It was a really fun time, but also a really bad time because there was a lot of issues with the first public version. It was definitely something really new, but something definitely very exciting. And shortly after, in the Dev Preview 2 is when they added USB audio support, which was a big deal for people who were kind of like recreate kind of like the Google Home in a sense. There was kind of like no way that you can actually output audio on an actual device when the first preview version actually came out. So the second version actually added that. All right, so in Dev Preview 3, they actually added support to the regular Bluetooth APIs that you'll normally use inside the Android framework. So if you were creating an app that unlocked a door via Bluetooth, you can actually kind of make your own IoT device on the side, essentially, with this API. And in Dev Preview 4, they added the audio APIs, which allows you to connect kind of like any digital audio device to it. So depending on your different use cases, you might want to not just go like the traditional auxiliary way. You can obviously connect like your Raspberry Pi to kind of just like whatever speaker that you have, kind of just like however you want. And 4.1 actually introduced Play services for IoT, which is kind of just like it has a reduced footprint versus like the regular Play services that we're all used to kind of, it's optimized to kind of work on these connected devices. Dev Preview 5 introduced the device manager service. This actually allows you to factory reset the device and restart the device. If you guys actually tried to do this with just like a regular application on an Android phone, you actually wouldn't be able to actually do this unless you have like system level permissions. So this new API that was introduced allows you to kind of just like be able to restart your IoT device at will. And 5.1 didn't actually introduce much, but they did fix a lot of issues that you've seen previously in the Dev Preview 5. And it wasn't until Developer Preview 6 where they actually introduced the Update Manager API, and kind of just like a way that you can kind of just like update your IoT device without actually having to have the actual physical device with you and having to manually load it. So you can actually manually check for updates and of course install. So Dev Preview 5, for any audio fans probably in the audience, you might like this, but they kind of like introduce a MIDI manager API that allows you, if you wanted to create like your own MIDI controller, or if you had like an external MIDI controller that you just wanted to use with your device for whatever use case it is, you can use this API. And shortly after, we had the first kind of like release candidate earlier this year, right before Google I/O, and literally a day before Google I/O, we finally got the actual first release, which is the 1.0 of Android Things. All right, so I'm gonna kind of talk about kind of like the differences between Android and Android Things. For the most part, there are kind of like four kind of just like topics that I'm kind of gonna kind of just talk about. Is this the API availability, the content providers, Play services, and permissions. These are like some key things that I found that is a pretty huge difference between working on a mobile device app or just and working with Android Things. So in terms of API availability, this is actually a full list of all the APIs that you actually cannot use. So because Android Things extends the Android framework, for every use case, you probably won't actually need all of these kind of just like these services and just these APIs in general, whether it's notification manager, because with Android Things devices, displays are actually optional. Unlike when you're working with like your regular like mobile device or tablet, like those actually have an actual display, and it's actually obviously needed. And for more information on kind of just like where you can actually find this list of Android Things, kind of just like the API availability, it's actually on the Android Things documentation website. So to get a bit into kind of just like content providers, so in general, I would just kind of as a rule of thumb, because technically there isn't any system apps actually installed on the actual IoT device ahead of time, just like it would be for your phone, avoid using common intents. So if I were to kind of just like have this code right here and run, it would probably crash as soon as you try to run it, because there's actually not an app that will actually kind of just use that intent. So you can actually like set an alarm. If you kind of need to do that, you'll most likely have to create kind of like your own alarm system, your own alarm app to actually live on it, and then you can actually open it yourself via your own intents. And to kind of just like fix any potential crashes that you can have. You can always use the has system feature method on the package manager class, and that would obviously fix all of the exceptions that you could potentially get trying to call these common intents. All right, so with Play Services, Android Things only supports a subset of the Play Services. For the most part, it's about the same, just small little changes. So in general, you're going to require at least version 11 of Play Services. And the app actually cannot target client SDK greater than the version that was bundled in target release. So because Android Things actually doesn't have a Play Store on it, the only way that you can actually like push updates to whether it's the Play Services version or just like the apps that's on it is pushing a brand new operating system update, which is what you can use like the Update Manager API that I mentioned earlier to actually kind of just like fetch that new version and of course install it. And on the left, you actually can see all the supported APIs, and obviously the unsupported APIs that you cannot use in Android Things. But for the most part, there isn't any code changes when you actually include it. Whether if it's for a mobile app, for an IoT app, if it's supported, it'll work literally the same way. All right, so with permissions are done completely different, essentially because of everything that happened in API level 2023, when you're essentially you have to prompt the user to actually allow or obviously deny specific permissions. But since Android Things kind of just like the displays are optional, you're not always going to have like that kind of like that user kind of interaction to kind of approve or deny it. So the way they kind of just like handled this was, in general, when you're working with Android Studio and you're loading it to like your Raspberry Pi or your device, the permissions are automatically granted by Android Studio by default. There's nothing that you actually have to do. If you do run into a kind of like a situation where you kind of do want to check kind of like what permissions you already granted, what permissions are denied, you can actually manually do it with this ADB command, and you can also revoke and of course grant permissions using this ADB command with no problem. If you kind of just want to test that kind of like the use case of would my actual device crash if for some reason it doesn't actually have the permissions. And of course, when you're actually ready to go from prototype to production, because this is mainly for like prototyping phase, when you're ready to actually go to production, what you normally would do is in the Android Things console, when you're creating the actual build for the operating system, you can actually grant all of the permissions that you want each app to actually have inside the Android Things console, which I won't really be getting into now, but it is similar to how the Play Store console works, but it's specifically for Android Things and pushing out updates. All right, so to kind of talk about hardware, these are the current list of supported platforms, which includes the Raspberry Pi. That's kind of like my favorite development platform to kind of use. These are kind of just recommended to use for development only because they actually do not kind of satisfy all the requirement needs that Google kind of needs. If you're going to production to these, you'll use the production platform. So the way Android Things is actually made, you don't actually have to necessarily do many code changes when you're going from a development platform to a production platform. The same code should technically work. You just have to wire it up specifically how you need it, and I'll get into that a little bit more later. And so production platforms are actually fully supported. They're going to get security updates for a minimum of about 3 years. So if you're thinking about using one of these production platforms, you don't have to. The key takeaway of kind of just like what Android Thing is, you do not have to worry about security. You're mainly just worried about kind of just like building the actual application and the use case and making sure obviously it runs. Google essentially takes care of everything else. So earlier I kind of spoke about the Android Thing support library, and we're kind of going to go a little bit into kind of just like the peripheral I/O APIs that Thing support library kind of just includes with it. So the first thing is GPIO, which is just general purpose input/output. These kind of hardware devices that you'll like use this API to support would kind of be like motion detectors, which are pretty straightforward. They're usually kind of just like pretty binary in terms of like it's either the voltage is high or the voltage is low, and then it just flips depending on the use case. And I'll be getting more into GPIO actually a little bit later. So PWM is actually used for motors if you need to kind of just need to kind of fine tune how much like I guess electricity that you're actually like voltage you're actually giving to these motors. If you wanted to go like faster or slower, most of the times you'll use a PWM API for this. Then we have the integrated circuit, which is used for like thermometers and accelerometers. And we also have the SPI, which is mainly used for like high bandwidth hardware, which would be like graphical displays. All right, so we're actually going to kind of just get into a little bit more code, and this is kind of just like my 3 steps to success of just kind of like creating a motion sensor driver. So the first step is actually to flash the image on the actual hardware. The second step is to connect the hardware, and the third step is to create the actual driver. So I'm not going to really get into how to actually flash an image on actual hardware, but there's a really good app in the Play Store called Android Things Toolkit that has probably like the greatest steps I've seen to actually how to actually flash an image. So I definitely recommend that. But in our examples that we're going to be using, we're going to mainly be working with the Raspberry Pi Model B, Raspberry Pi 3 Model B, and it'll be pretty simple. So on the left, you'll actually see a pinout this is a pinout diagram of the Raspberry Pi Model 3. This actually changes for depending on what development platform that you're looking for, but it's fairly the same. You're gonna have like the 5-volt pins. You're gonna have like your regular GPIO pins. You're gonna have ground pins. It all depends on kind of like the hardware and what kind of specs that the actual hardware itself needs, and then you'll kind of figure out where you should actually connect them. So, all right, so GPIO, so all the GPIO pins that you actually see here, they're actually green. So the actual like name right next to them is a name that you basically use. So when you're actually opening the pin, which I'll get into later. So this image here is essentially how we're actually connecting the motion detector to the actual Raspberry Pi. So as you can see, kind of like the red wire is actually connected to the 5-volt pin because the actual motion sensor itself obviously needs power, and the yellow one is actually connected to the BCM4 GPIO pin, and that's just for you to whether. That's what you should be listening to whether or not if you know that the actual motion sensor itself is detecting something or doesn't detect something, and of course the black wire goes straight to ground. Okay, so moving on to creating our first driver. I'm actually using Android Studio 3.14 in this version. It might change a bit depending on what version that you're using. So I'm just going to name the application Intro to Android Things, and I'm going to choose kind of just like the Android Things empty activity. And one thing I'm going to do is, of course, uncheck generate UI file, because in this example we actually do not need a display because we're not actually connecting the display to this device. So once the actual project actually finished compiling, the first thing you'll probably want to do is go to your manifest and actually add this permission there in order to actually be able to interact and use kind of like these GPIO pins and kind of like the APIs that I mentioned earlier. So this is actually a method that I actually created inside of a class. It could literally be named anything. Just know that this method right here is called in the on start of the activity, and I do have a close that I'll show you later, and of course it's going to be called an on stop. So just going through kind of going through it line by line. So the first thing that we're going to do is going to open a GPIO pin. So if you remember from the diagram that I showed you earlier, the yellow wire was actually connected to the BCM4 GPIO pin, and that's essentially like the pin that we're going to listen to that kind of gives us all the data that we actually need on whether or not the motion detector actually detected someone or didn't detect someone. So we actually going to set the actual direction as an input because we're reading the input from the actual device from our actual device. And we're just going to set that the active type is so in general when you're working with GPIO, it could be either high voltage or low voltage. So with the motion sensor whenever it's high, it's considered active. That means that it actually detected someone. And for the edge, for the trigger types, I'm putting for both. So whenever it changes from low to high, we'll get a callback. Whenever it changes from high to low, we'll also get a callback. And of course, we want to register our GPIO callback, and I'll actually get into how that actually looks in this next slide. So it's pretty straightforward. All it is checking. So whenever there's a change in terms of low to high or high to low from the actual motion detector, it'll actually do this callback, and obviously if the value is true, then that means that we detect the motion, and after like every couple seconds or so, depending on how you set up your motion detector, it will actually go back to low, and that means that it didn't detect any motion for like the past 2 seconds or whatever you actually specified actual motion sensor to basically poll for. And of course, just gonna return true, just so it can continue listening to changes. Depending on your use case, you probably don't always want to keep listening to changes, but in this specific use case, we want to keep kind of just like listening to changes and make sure that we're kind of getting those signals of like when it actually goes from low to high or high to low. And this is actually a closed method that I actually showed you earlier. Just make sure that you, of course, unregister your GPIO callback, and of course, close the actual GPIO pin, because it can obviously go from kind of just, I don't know, 0 to 100. Yeah, so these are actually kind of just like some helpful links that I actually found like kind of through my journey of kind of just learning Android things. The Google Plus community is pretty really good. There's actually a link I didn't include here. There's actually a subreddit for Android things that's really helpful. And of course, the Android Dev subreddit is also really helpful for people who just kind of just looking for kind of just ideas of kind of like what you can make and kind of just like what Android things can potentially do. I definitely recommend looking at Hackster. There's a bunch of projects that's actually on there, and they actually usually give you kind of like the step-by-step solution of how you can actually create it yourself if you're also interested in creating that. So today we kind of went over kind of like what is Android things and kind of just like why you should use it, and kind of just like the differences between the Android framework and obviously the Android things, and kind of just like a brief history of Android things. So for like a Android engineer or like myself who likes creating kind of like these connected devices, I felt like Android things kind of like the solution I was looking for, because there was kind of just like there isn't that much extra info that you actually need to know outside of like your domain of just Android development. So it's really just, I feel like it's tailored to more people who are familiar with Android development, but kind of want to get into like this IoT space where you can kind of create something from nothing. I'm definitely excited to see what the Android community is actually going to build kind of with Android things. But I definitely recommend looking at these websites if you have any more information.